250 miles or 400 kilometers above the Earth is perhaps one of the most insane structures ever constructed by humans. Leading the way in science and technology, this engineering wonder is a collaboration between 15 nations, including the United States, Russia, Japan, Canada, and several European countries. Meet the International Space Station, humanity's attempt to colonize the stars. But what exactly is the International Space Station? How was it built? And how could this megaproject, the biggest symbol of peace and unity today, be born out of one of humanity's worst wars? From religion to art, for as long as civilization has existed, humans have been completely fascinated by the stars, making their way into songs, movies, stories, and so much more. These heavenly bodies have not only shaped our night sky, but also the culture and mindset of countless humans worldwide. The dream was to live among the stars.
On November 20th, 1998, the first piece of the International Space Station launched into orbit.
And on November 20th, 1998, the world watched with excitement as our collective dream became reality, all thanks to the International Space Station, or the ISS for short. Shining as one of the brightest objects in the night sky, the ISS is quite literally the equivalent of a 5-bedroom house, the size of a football field, flying around Earth at 17,500 miles per hour, or 28,000 kilometers per hour. At this speed, the megastructure circles the Earth once every 90 minutes and is about 23 times faster than the speed of sound. Visible from Earth as a fast-moving bright dot, the ISS is an engineering marvel that can't help but leave you speechless. Standing at about 72.8 meters, or 239 feet, the ISS is nearly as long as 3 standard school buses parked end to end. The massive structure boasts a width of 108.5 meters, or 356 feet, which is about the same width as a Boeing 747 jetliner, wingtip to wingtip. But that's not all, because the ISS stands at around 20 meters, or 66 feet, making it as tall as a 6-story building. However, filled to the brim with technological parts and machinery, the interior habitable volume of the ISS is about 388 cubic meters, or 13,696 cubic feet, and is roughly equivalent to the volume of a 5-bedroom house. In total, the ISS weighs about 420,000 kilograms, or 925,000 pounds, the equivalent of a whopping 320 average-sized cars. As you can imagine, with stats like these, the ISS was anything but cheap. In fact, it stands today as the most expensive structure in all of human history. A beacon for peace and unity, the project took 10 years, 36 separate trips, 15 collaborating countries, 5 space agencies, and the supervision of experts from all around the world to build. According to estimates in 2010, the project cost about $150 billion to build, with each of its 36 trips costing around $450 million to $1.5 billion, depending on the mission. Now, that is ridiculous, yes, but you have to remember that the bulk of the $150 billion was spent on developing, building, and operating the ISS, and was sourced through contributions from all the participating countries. Today, the ISS is a hub for technological advancements and scientific research, and is considered a sign of peace among nations. But that wasn't always the case, because this insane engineering feat, with all its bells and whistles, was actually the result of one of the scariest wars The beeping signals from Sputnik's radio transmission were like a cosmic alarm bell for the United States, signaling that the Soviets were pulling ahead in technology and military capability. The US, aiming not to be outdone, decided to strike back. They launched Explorer 1 on January 31, 1958, the same year that NASA was formed. Explorer 1 was largely a successful mission, and it even went on to discover the Van Allen radiation belts around Earth. The race was on, and both sides were determined to win. However, the Soviet Union was clearly in the lead. While the US was scrambling, the Soviet Union continued to rack up victories, as on April 12, 1961, Yuri Gagarin became the first human to orbit the Earth aboard Vostok 1. As you can imagine, this achievement was a massive propaganda win for the USSR and made Gagarin an international hero. But the Soviets didn't stop there, as they followed this up with more firsts, including the first woman in space, Valentina Tereshkova, in 1963. Not to be outdone, President John F. Kennedy made a bold promise in 1961. The US would land a man on the moon and return him safely to Earth before the decade was out.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon.
Its orbit decayed, leading to its unplanned fiery re-entry in 1979. But the US wasn't the only one experimenting with space exploration. Size of a football field, while its parts were traveling 23 times faster than the speed of sound. The idea of a space station goes way further than around which the rest of the ISS would be built. Shortly after Zarya, NASA launched the Unity module, which served as the central connecting node, allowing future modules to be attached. Unity was the first American component of the ISS, and its launch marked the beginning of a new era of international collaboration in space. Over the next several years, additional modules were attached, each bringing new capabilities to the station. These included laboratories, living quarters, and massive solar arrays that would provide the power needed to support the station's growing infrastructure. As each module was launched, it had to be docked and attached to the existing structure with extraordinary precision. As such, the Russian modules, such as Zarya and later additions, used advanced automated docking systems that allowed them to approach and connect to the ISS autonomously. However, much of the assembly work required human intervention, and this is where the ingenuity of engineers shone through. One of the most critical tools in the assembly of the ISS was the Canadarm2, a robotic arm designed and built by the Canadian Space Agency. This versatile tool became the workhorse of the ISS assembly process, enabling astronauts to maneuver large modules with precision and ease. You see, Canadarm2 could grapple and move massive structures, making it possible to attach new modules to the ISS with a level of accuracy that would have been otherwise impossible. This robotic arm was not just a piece of equipment. It was an extension of the astronauts' own hands, capable of performing tasks that would have been too dangerous or physically demanding for a human to do directly. However, not everything was autonomous, as despite the sophistication of tools like Canadarm2, many of the connections and installations required the hands-on skills of astronauts performing spacewalks. These spacewalks, or extravehicular activities, were carefully choreographed and required astronauts to venture outside the relative safety of the ISS to manually connect cables, install hardware, and conduct repairs. Now, this wasn't just your average walk in the park, as the environment outside the ISS is incredibly hostile, with no atmosphere, extreme temperatures, and the ever-present danger of micrometeoroids. Yet astronauts undertook these missions with precision and calm, knowing that every action they took was vital to the success of the ISS. In fact, the longest spacewalk lasted 8 hours and 56 minutes during STS-102 for an ISS construction mission in 2001. It was performed by NASA astronauts Jim Voss and Susan Helms. In addition to the physical challenges of constructing the ISS, engineers had to contend with the harsh conditions of space. The station orbits Earth in a region known as low Earth orbit, where it's exposed to extreme temperature fluctuations. On one side, that is, the sunny side, temperatures can soar to 121 degrees Celsius or 250 degrees Fahrenheit, while on the other side, the dark side, they can plummet to minus 157 degrees Celsius or minus 250 degrees Fahrenheit. To protect the station and its inhabitants, engineers developed sophisticated thermal control systems that could regulate the temperature inside the station, ensuring a stable environment for both the crew and the sensitive scientific instruments aboard. But that wasn't all, because another critical concern was the threat of micrometeoroids and space debris, which travel at incredibly high speeds and could cause catastrophic damage to the ISS if they were to strike it. To at least control this risk, the ISS was equipped with micrometeoroid shielding, a protective layer that could absorb and deflect the impact of small particles. This shielding was vital for the station's longevity, as even tiny pieces of debris could cause significant damage at such high velocities. Constructing the ISS was not just a technological challenge, it was also a monumental exercise in international coordination. Different modules of the ISS were built by different countries, each with its distinct engineering standards and practices. Harmonizing these disparate systems to ensure they would work together in space required extensive collaboration and meticulous planning. The assembly process was supported by regular supply missions that delivered the materials, equipment, and provisions necessary for the station's construction and operation. These supply missions were carried out by various spacecraft, including the now retired Space Shuttle, Russian Progress vehicles, and more recently, commercial spacecraft like SpaceX's Dragon and Northrop Grumman's Cygnus. These missions ensured that the ISS had everything it needed to remain operational, from basic life support to advanced scientific instruments. There was even a time in 2001 when the ISS received a 6-inch pizza from Pizza Hut. The construction of the ISS didn't end once the initial modules were assembled. Over the years, the station has seen numerous upgrades and expansions. A good example is Destiny, the US laboratory module that became part of the station on February 7, 2001. The lab was quite iconic as it increased onboard living space by 41% and continues to be the primary research laboratory for US payloads today. The European ESA also sent a lab on February 7, 2008, and was quickly joined by the first Japanese Kibo laboratory module on March 11, 2008. Ranging from new solar arrays to communication systems and scientific instruments, these new add-ons help keep the ISS at the cutting edge of space technology. It's this continuous evolution that's allowed the ISS to remain a vital platform for research and exploration, even as it's aged. If you think it can't get better than this, then you need to hear about the ISS self-sustainability systems. The ISS is equipped with advanced life support systems to maintain a self-sustaining environment. For example, it recycles about 93% of water from urine, sweat, and wastewater, making it safe for reuse. And like in a sci-fi movie, oxygen is generated through electrolysis, which splits the water on board into oxygen and hydrogen. There's also a carbon dioxide removal assembly that scrubs CO2 from the air, and a subache system that converts the CO2 and hydrogen into water and methane, providing additional water. Essentially, nothing is wasted, and the ISS is perhaps the world's best example of closed engineering. Even the waste is either stored for return to Earth or compacted and burned up upon re-entry. For electricity, solar arrays the size of a football field are used, with excess stored in batteries. Essentially, these systems ensure the ISS can support human life for extended periods, which is crucial for future deep space missions. Today, the complex offers more living space than a typical 6-bedroom house, featuring 2 bathrooms, gym facilities, and even a 360-degree bay window. NASA astronaut Bill Shepard, along with cosmonauts Yuri Gudzenko and Sergei Krikalev, became the first crew to live aboard the station. During Expedition 1, they spent 4 months on board, performing essential tasks to bring the ISS to life and initiating what has now become over 20 years of continuous human presence in space. Usually housing about 3 to 6 astronauts, the ISS can, at its maximum capacity, sustain life for 13 people, with its staff being rotated every 6 months. However, that isn't always the case, as Russian cosmonaut Oleg Kononenko became the first person to spend a cumulative 1,000 days in space. So, what do scientists do on the ISS? Once aboard the station, astronauts typically spend about 6 months conducting various scientific experiments and performing maintenance and repairs on the ISS. Some of the major breakthroughs from these scientific experiments include the first plant grown and eaten in space, advancements in bone and muscle research that have improved osteoporosis treatments, and even the development of water purification technology used in developing countries. The ISS has also contributed to understanding fire behavior in microgravity, tissue and organ research, and even provided insights into climate change through Earth observation. Beyond their work duties, astronauts dedicate at least 2 hours daily to exercise and personal care. Of course, they also engage in spacewalks, participate in outreach events with schools and the media, and share updates on social media, with Mike Massimino becoming the first astronaut to tweet from space, doing so from a space shuttle in May 2009. The ISS bedrooms are equipped with small bunk beds where astronauts can either tether themselves to a wall or float freely in the confined space, depending on their preference. For crews visiting temporarily for just a few days, sleeping arrangements might include staying in their spacecraft or finding a spare spot on the station, as long as they tether themselves securely in space. Although one of humanity's greatest achievements to date, the ISS still has some issues, including aging hardware that requires constant maintenance and repairs, limited storage space, and the ongoing challenge of micrometeoroid impacts, which can cause damage to the station's exterior. The station also struggles with the harsh environment of space, leading to issues like equipment degradation due to extreme temperatures and radiation. Additionally, the crew faces physical and psychological challenges, including muscle and bone loss, radiation exposure, and the mental strain of long-term isolation. However, one of the biggest problems remains funding and international cooperation, which are today an extremely critical concern for the future of the ISS. NASA and other space agencies are committed to fully using and safely operating the space station up until 2030. The ISS remains our greatest creation in space, but not for long, as like a father passing on his legacy, the ISS has opened the gateway to space exploration and has even made room for commercial space exploration. With companies planning hotels in space and joyrides around the Earth, this megastructure born from war and made for peace continues to not only bring us together, but also push what it means to be human, what it means to create, and what it means to be a citizen of the universe. But what do you think? Is the ISS outdated? Would you like to visit it? And how much do you think a space hotel room would cost? Let us know in the comments section below, and let us know what topic you'd like us to cover next. If the ISS interests you, then you have to see what Saudi Arabia is building in Riyadh. Who needs space when you have the metaverse? Just click this video right here. Leave a like and subscribe if you enjoyed the video, as it helps the channel and it will keep you updated on all the most iconic engineering feats in the world. Until next time, keep on dreaming. Bye for now.